Okay, welcome to the Chapter 5-2, so Chapter 5, Section 2 on molar mass. We're going to look at how we can calculate the molar mass of a compound. Basically, this is just summing up all the atomic weight of each atom in a compound using the periodic table. Okay, so wherever you see formula weight and molar mass are used interchangeably. But your book wants you to put in the units of grams per mole, because that's what we're going to be using when we do calculations. So anywhere you see AMU, this can also be grams per mole. Okay, so what we're going to do, so here we have propane, C3H8. All we do is go to the periodic table, look for the atomic mass of each of our components. So if we go to the periodic table, we have 12.01 grams per mole, or AMU. And we have 3 carbon atoms in our compound, so we have to multiply 3 times 12.01 to give us 36.03 grams per mole. Okay, we've got 8 hydrogens, so we've got to multiply 8 times the atomic mass. So these numbers here come from the periodic table, and you'll be given one of these. What I also want you to do is just use the number that is exactly what's on the periodic table that I give you. Okay, so you won't have any question of, what do you round to, that kind of thing, or how many numbers do you use. Your book, I think, uses 3 significant digits. So, but you'll just use exactly what's on the periodic table. Okay, so 8 times 1.01 gives you 8.08. Okay, and then you just add these up. 36.03 plus 8.08 gives you 44.11 grams per mole. So this is the molar mass of propane. Okay, once again, formula weight, molecular weight, molar mass. Your book uses molar mass, so these are the same thing. Okay, so this is about as hard as it will get if you've got a polyatomic ion. So here you've got calcium nitrate, so calcium nitrates are compound. All right, you have 1 calcium in the compound, so you would multiply it times its atomic mass from the periodic table. So you can pause if you need to get your periodic table out and check these values. Okay, and here AMU, like I said, can be stand for just grams per mole. So technically this should be grams per mole here in the answer. Okay, we've got 2 nitrogen. Okay, the number that's outside the parenthesis is multiplied through the elements or the atoms in the compound. So nitrogen has an understood 1, and so you multiply it times 2. 1 times 2 is 2. So we have 2 nitrogen, so 2 times 14.01. This comes from the periodic table, all of these numbers here. We get 28.02. We take 6 times oxygen, because we've got 3 times 2. We've got 6 oxygen atoms. 6 times 16 is 96. And then if you sum all of these numbers up, you get 164.10. Okay? I'll give you a hint here for this next practice problem. It wants the molar mass of acetic acid. Okay, and molar mass has the units of grams per mole, so we'll change this. Okay, so I'm going to give you the formula for acetic acid. And so if you look these up, so you can pause if you want to work it yourself, but I'm going to go ahead and keep going here. So we've got 2 carbons, 1, 2. We've got 4 hydrogens. And we've got 2 oxygens. Okay, so if we look up carbon, it's 12.01. Hydrogen is 1.01 AMU or grams per mole, and oxygen is 16. So if we take 2 times 12.01, we get 24.02, and 2 times 16 is 32 for our oxygen, and then if we take 4 times 1.01, we get a 4.04. So when we add all these up, we should get, my answer should pop up. It's not. Okay, so if we add all these up, we should get 60.06 grams per mole. So this is the molar mass of acetic acid, which is a very common reagent in chemistry. Okay. Okay, so here is the answer. Came up now, finally. All right, so this is how we come up with molar mass. So easy enough. Use the periodic table, multiply times the number of atoms that you have, and voila, you have your molar. Okay, so how can we use our atomic masses, and which we've now come up with molar mass? So how can we use these molar masses in our chemical calculations? This slide is super important because we're going to learn how to go from grams to moles and moles to grams. Okay, so if you were in a laboratory and I asked you to weigh out 4 moles of a compound, okay, it would be kind of hard for you to do that if you didn't know how to convert from moles to grams, because our balances weigh in grams. So if I said to you 4 moles, you may look at me like I don't know what you're talking about because I can't weigh out 4 moles. Okay, but you can, because you can convert from moles to grams. Okay, so that's why our relationship of the periodic table is based upon 1 mole, and the amounts there can be also in grams. We can look at them as being in grams. Okay, so what we do, just like we've done before, we are going to write out what we know. Okay, so we are going to be going from moles to grams. Okay? It is imperative that you know how to do these problems. So be sure, even after we do some practice, that you go to your homework, your book, or the extra practice problems on Blackboard. Okay, so here we are going from moles to grams. Okay, it's going to be one step. All right, and so what we have to do is we have to think about what's our common relationship between moles and grams. Okay, it's going to be our atomic mass from the periodic table, and we know that all of those masses are based upon 1 mole. So technically, this would be 1 mole. And then what we have to do is add up the molar mass of SO2. Okay, so if we look at the periodic table, sulfur is 32.07, oxygen is 16 times 2, and this should give us about 64.07 grams per mole. Okay, see how our units are grams per mole? So if we plug in here, we've got grams here per mole in our denominator, just like we have here with our units. So our moles cancel. We've got to be sure that we have our compound there. Okay, so if we take our 4.00 times 64.07, and basically you multiply everything on the top, divide it by the numbers on the bottom, which is 1 in this case. So we get about 256 grams SO2. Okay. In our next problem, we're asked for moles, and we're given grams. So we have grams, and we're going to moles. So we write out what we know. As always, go ahead and write our, so we've got water. Got to be sure we put our compound. Okay, so this time it's just going to be the reverse of this up here. Okay, because we have grams on the top, we've got to have grams on the bottom. Okay, so if we add up the molar mass of H2O, it's going to be 16 plus 0.01 times 2. So that gives us like 18.02 grams per mole. Okay, so this is the molar mass of water. Okay, so we are now going to put that number on the bottom because that's how many grams we have. And we know that when we look at the periodic table, it's always out of 1 mole. So in this step, from grams to moles, you can not have a number higher than 1. It's going to be 1 every time. Okay, so grams cancel, and now if we divide 15.25 by 18.02, we get 0.8463 moles of water. Okay, we're going to do a couple more problems, and hopefully you haven't forgotten about Avogadro's number, because we're going to use that as well. Okay, so we're asked for how many moles for part A are contained in 60 grams. So we know the first thing we do is write out what we know and put our units on top and bottom to cancel. We're asked for moles. Okay, so we know whatever's left on top not canceled out, and in the right units and the right compound, then you can stop. Okay, so here it's just going to be one step. Okay, so if we calculate our O3, so ozone, so it's going to be 16 times 3, so we get 48 grams per mole of ozone. Okay, so this number goes here, because grams has to be on the bottom because these have to cancel, and we know this is always based upon 1 mole. So anytime we go to the periodic table and we get our molar mass, it's based on 1 mole. Okay, so if we take 60.0, divide it by 48.00, we get 1.25 moles of ozone. Okay, the next one, ask for molecules. So remember, for ask for molecules, we automatically have to think about Avogadro's number. And we know that Avogadro's number is based upon 1 mole. Okay, so we're given grams. Okay, so we're going to write it out again. Okay, so we run into a problem. We can't just plug in Avogadro's number because we're in grams. We're not in moles. Okay, so we've got a mole up here. That's not going to fit down here. Okay, so what we have to first do is convert from grams to moles, just like we did up here. So basically we could have just kept going from up top, but for practice we'll go ahead and put in the same thing. Okay, so now we've already added up our molar mass of ozone, and that's in 1 mole of ozone. Okay, but we're not asked for moles of ozone, so we can't stop like we did in A. We've got to keep going. Okay, so if we have moles of ozone up top, we've got to have the same units on the bottom. Okay, so that these can cancel. Okay, if we hear the words molecules, particles, atoms, we know we have to use Avogadro's number, but how are we going to use it? Okay, we're not going to put the number here, 6.02 times 10 to the 23rd. We're going to use 1 mole, right? Because Avogadro's number is based on 1 mole. It can't ever be anything different than that. Okay, so we have 1 on the bottom, and then we know in 1 mole we have 6.02 times 10 to the 23rd molecules of ozone. So now our moles cancel. We have molecules of ozone left uncrossed out, and on the top it's got the right units, so we can stop there. So if we take 60.0 multiplied times 1 times 6.02 times 10 to the 23rd, okay, and we're going to divide by everything on the bottom, so 48 times 1, so 48. Okay, we should get something like 7.53 times 10 to the 23rd molecules of ozone. So you want to be sure that you know how to use your calculator, because it is very easy to not use it correctly and then you'll get the wrong answer even though you set it up correctly. Okay, so this should be what you get here. Okay, now go do some more practice on homework in your book or on the extra handout. Thank you, and I will see you in the next video.